Question 28, we're looking at the ratio of hydrogens in the following molecules. So the first step, which should be true for all of these, I'm going to draw it a little bit bigger for this first step, is to actually show all the hydrogens. So hydrogen, 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 more hydrogens. And because I have colors, what I would go through and do is actually color these, so that's what I'm going to go through and do. So I'm starting with the red, whoops, and I'm misdrawing, and the other hydrogens at the end. So for identifying our ratio of hydrogens, we need to know the equivalencies. So how many unique hydrogens are there? Okay, well, I'm going to start, I don't know why, but I'm starting at the right-hand side of the structure. All three of those hydrogens are identical to each other. Due to a line of symmetry running through the molecule, the hydrogens on the far side are also identical to those original pairs. Okay? Adding to that, let's see, does that orange show up? Maybe it shows up. That hydrogen will then be identical to the one across from it, again due to that line of symmetry. There's another line of symmetry, which I'm just going to show as a solid line, running right through the middle of the molecule, meaning the hydrogens on the opposite side are also identical to the original. This means there's really only two hydrogens, or two types of hydrogens. The blue hydrogens, which were 6 hydrogens, will then be compared to the orange hydrogens, and there were 4 of those. Okay? Because HNMR shows reduced ratios, or an empirical formula, we're probably fishing for the answer where we divide both those answers by 2, we get 3H to 2H. But both of those answers would potentially be valid. If we go back and look at the answer choices we've got, the 311 from A is assuming all hydrogens are different from each other. Well, they aren't, so that one's false. 343 at least acknowledges that the aromatic hydrogens are the same as each other, okay, but it doesn't identify that the methyl groups are the same. That one's false. And then 3,2, that one is our exact ratio. The 6,2 doesn't make sense because there's 4 aromatic hydrogens running through that middle, so the 2 doesn't make sense. That would be our answer to question 28.